In this video, I'll explain two important concepts: pull-up resistors and pull-down resistors. If you're just getting started with Arduino, understanding these circuits will make it much easier to work with push buttons and other input devices in your projects. Both pull-up and pull-down circuits use two basic components: a fixed resistor, usually between 1 kiloohm and 100 kiloohms, and a switching device with very low resistance, such as a push button. Let's start by seeing how each circuit is connected. To build a pull-up resistor circuit, connect a fixed resistor between the voltage supply and the signal line, just like this. To build a pull-down resistor circuit, connect a fixed resistor between the signal line and ground, as shown here. Now that we've seen how to connect them, let's understand what each one does. A pull-up resistor keeps the signal line at a high state by default. When the switch is open, the resistor pulls the signal line up to the supply voltage, so the output stays high. When you press the switch, the signal line is connected to ground, causing the output to become low. So, whenever you want Vout to be high by default, and low only when the button is pressed, you should use a pull-up resistor. A pull-down resistor works in the opposite way. It keeps the signal line at a low state by default, by connecting it to ground through the resistor. When you press the switch, the signal line is connected to the supply voltage, causing the output to become high. So, whenever you want Vout to be low by default, and high when the button is pressed, you should use a pull-down resistor. Now, let's compare the two circuits side by side. As we learned earlier, when the switch is open, each circuit has a different default logic state. In a pull-up circuit, the signal line is high by default. In a pull-down circuit, the signal line is low by default. Now let's see what happens when the switch is closed. In a pull-up circuit, pressing the button changes the logic state from high to low. In a pull-down circuit, pressing the button changes the logic state from low to high. So, the main difference is the default state of the signal line and how it changes when the switch is pressed. Pull-up and pull-down resistors are essential in digital circuits, because they keep an input pin at a known logic state. They also prevent the input from picking up random electrical noise from the surroundings, which can cause false or unexpected triggers. Let me show you what happens without one. Here, I've connected a breadboard wire to Arduino pin 3, uploaded this simple sketch, and opened the serial monitor. Now if you observe the serial monitor, let me pause this so that you can observe the change. Now if you observe how the logic level is changing from high to low at random. This happens because the input pin is floating. It can easily pick up tiny electrical signals from its surroundings, even from your hand. And this is just one example. There are many external sources that can interfere with the floating input pin. To prevent this, we use a pull-up or pull-down resistor circuit. Now I've connected this pull-up resistor circuit on the breadboard. Now if you observe the serial monitor, the logic level is fixed to high as intended for the pull-up circuit. The logic level will only change when the button is pressed, so giving us a stable and reliable input data. Pull-up and pull-down resistors have another important job. They also help limit the current and prevent a short circuit when the button is pressed. To understand why, let's imagine the circuit without a pull-up or pull-down resistor. Without the resistors, the circuit will look something like this. Now, if you press the button, the positive supply would be connected directly to ground through the switch. This is similar to connecting the positive terminal of a battery directly to its negative terminal with a wire. Since there's almost no resistance in the path, a very large current can flow, creating a short circuit. To prevent this, we add a pull-up or pull-down resistor to the circuit. The resistor acts as a current-limiting component, allowing only a very small amount of current to flow when the button is pressed. This protects the circuit while also keeping the input pin at the correct logic state. Both pull-up and pull-down resistors also ensure minimal current leaks through the circuit during the inactive state. That's it for this video. Thank you for watching. Please don't forget to like, share, and subscribe with notification.